In today's video, here is a nice inequality. It's coming from the Russia. Here is the following information: for all x, y as a real number, satisfy this following inequality. Okay, so our goal, we are going to prove this statement: cosine x plus cosine y plus twice cosine of x plus y is strictly superior than minus 9/4. Okay, since you have a minus sign here, which means cosine x and cosine y, both of them, they could be positive or negative. Okay, so as we know, cosine x and cosine y is always located between minus number 1 and 1. Okay, so we have this combination. Now we are going to prove this one is always strictly superior than minus 9/4. Okay, as we go with the solution, we are going to expand this one out. I'm going to put this one on the form of cosine x and cosine y. Okay, so we have cosine x plus cosine y plus 2 times, I'm going to expand this one, is the same as cosine x is multiplied by cosine y minus sine x is multiplied by sine y, which is strictly superior than minus 9/4. Okay, we are going to solve this inequality as it is. At the end, we will find this one is true for all x and y. Okay, so we get here cosine x plus cosine y, all is raised to number 2 as a power. So when we distribute this one, we get, but we have only 2 cosine x cosine y, which is this one, so we need to subtract that. We are going to put this one as minus cosine square x minus cosine square y minus twice of sine x is multiplied by sine y, so which is strictly superior than minus 9/4. Okay, we have minus cosine square x is going to be replaced with, so we get here cosine x plus cosine y square plus sine of square x minus number 1. This argument follows similarly for cosine square y, which is going to be sine square y minus number 1. I'm going to split this one into 2 parts. I got minus sine x sine y minus sine x sine y, which is strictly superior than minus 9/4. Okay, we got sine x here, we got also sine x here, we got sine y here, we got sine y here. Okay, so I'm going to take sine x as a common factor for these 2 terms and taking sine y as a common factor for the second term. Okay, what's gonna happen here? So we get here cosine x plus cosine y, all is raised to the number 2 as a power, plus sine x factor sine x, this one is going to be multiplied by itself, minus sine y. I'm going to put here sine y as a common multiplier here, which is multiplied by sine y minus sine x, strictly superior than minus 9/4. I'm going to move over this minus number 2 because minus 1, which is minus 2, I'm going to move it over to the other side of the inequality, so it becomes plus 2. If I'm going to calculate this one, is going to give us minus 1/4. Okay, so I have sine x minus sine y, and also if I'm going to take this minus sign out of these things, becomes sine x minus sine y is going to be taken as a common multiplier. So we get cosine x plus cosine y quadratic square plus sine x minus sine y is going to be multiplied by sine x as a first term, then minus sine y sine y. Okay, everything is strictly superior than minus 1/4. Now next thing coming up, if you take a look at this term and this term are the same, so this one is going to be a perfect square here as well as this one. So thus I get cosine x plus cosine y is going to be raised to number 2 as a power as a perfect square, plus sine x minus sine y is raised to number 2 as a perfect square, which plus 1 over 4, which is strictly superior than 0. Okay? Then now, if you take a look at this term, this one is superior to 0, as well as this one, which is true. Okay? Which is verifying our inequality. Which means this inequality have been proven is true statement. Okay? So I have ended this video. Thank you for watching. I'll see you next video. Bye.